All right, we're back. I realized I forgot to ask how everyone was doing this morning. And let's see. Where are you all from? It looks like we've got a few people from San Francisco today. And a few from Europe. And let's see, Mikey, did you say you were from the East Coast, US? I forgot. So, let's see. Yeah, I said I did want to do colors real quick. So let's at least put a few in. Oh, you're from Israel. Cool. And San Francisco via Dublin. Cool. Let's see. So colors. So we have our color. So this should be pretty easy. Actually, why don't we make a new function for this? Determine color takes an int and gives back a string. So if we have iterations less than 1, then we'll do yellow. Otherwise, we'll do orange. Let's start with that. And then now, this gets a bit simpler. We can just use a maybe dot map, determine color, and then a maybe dot with default of black. Let's try that out. And maybe I will shrink this back down a little bit, about 200. There we go. So let's just stick a few more in. Else if iterations. Nah, I don't know if anyone knows of like a package that has a good function that could help us pick a color like out of a looping list. Guess we could use mod for that. But I'm not going to get this too sophisticated here. There we go. Three. And 4. We'll do pink here, purple here. No, that's not a good color. Let's see, I don't know all my CSS color names. Yeah, there we go. That looks good for now. So yeah, basically, just depending on how many iterations. Oh, actually, okay, this should be easy to make it cycle. Let's just define x equals iterations mod 5. And then we'll change this to x. There we go. That's the Mandelbrot set I remember. Cool. So, no, it seems like a lot of people in chat are familiar with the Mandelbrot set and have played with it before. So for anyone who doesn't know, basically it's a fractal, meaning it's self-similar, but there are other much simpler fractals. The Mandelbrot set is particularly interesting because, like, if you zoom in on any of these bulbs that stick out from the center, you'll see similar structures to the entire thing itself. But it's not exactly the same, and every time you see something similar, it's always like twisted or skewed or different in some way. So, zooming in is definitely one of the most interesting things with this. Let's see. So let me catch up on the chat. Oh yes, Please Fixpoint mentions that instead of checking that the absolute value here is within 2, we could also just check that the square of that is less than 4, so that we avoid calling square root. That's true. It would also mean we'd have to make our own function to do that squaring. Oh no, actually, that should be an easy fix to make. Let's actually do that optimization. Alright, so here we are, adding colors. And Lily's asking if we need to pass max iterations in. We actually don't right now because it's defined at the top level, but I kind of want to keep it as a parameter just so that it's easy to change later. Let's see. So, we reload this. Takes less than a second to load. Not sure if I'll see a difference, but let's change this to, say, complex.mult z z, and then we need to take the size of that. Oh, does that actually work? You get more speed. Yeah, I think we'd have to write our own function to optimize this. So I'll skip that for now. If I'm wrong, feel free to implement it as an exercise for yourself. Yeah, Mikey, I don't think you can save the chat between refreshes on Twitch. Although you can actually log into Twitch via IRC clients, I think. I haven't actually done that. All right. So I think people were wanting to see how to make this do incremental computation. I am kind of interested in trying that out also. So let's think through how this is going to work. I think we have a nice module here that can compute individual rows and cells if we want to. So I'd like to make a new module that wraps this and does the asynchronous, or like splits the computation into multiple update cycles. So I guess the way this will work is we're going to start out by, I guess we can start out just with the empty model, and then we'll create a command, and every time we get the command, we'll calculate the next row, and then we'll just fire those off. So I guess we'll calculate the next row and then also send another command that on the next update cycle will give us the message to calculate the next row. I don't know if I'm explaining that very clearly, but I think I have enough of an idea in my head to get started. So let's call this incremental Mandelbrot.elm. And this should just be able to build on top of what we've already built. So we're going to have an init. We're also going to have, do we need a model? I guess we may as well have our own model. We're going to have our message. We're going to have an update function, and we're going to have a view function as well. Actually, some of these are just going to proxy the Mandelbrot part. But in fact, we can probably generalize this in the future so that it could work with different types of fractal generators. So let's make our model. For now, I don't think we need, well, okay, I guess we need two other things. So we'll have the fractal, which will be the Mandelbrot.model, and we'll have a next row, which will be an int. And then we're going to have our init, which is actually going to produce a model and a command of messages. So we're going to have our fractal will be Mandelbrot.init. Can't type. Fractal. And our next row is going to be row 0. And then we're also going to have, let's see, I haven't done this in a while. Is there a succeed? I don't think I haven't played a lot with commands in 0.17. So what do we have here? We've got a none. I guess all we need is a task.succeed. Then we'll turn that into the command. Oh, thanks, Arkham. Yeah, I always forget to post this in the Elm Slack. And yeah, Mikey, that Elm Web Workers thing that Richard wrote is I don't know if we could use it here, but basically, I don't think it's implemented for browsers yet. It's mainly used by his Node test runner to try to parallelize execution of unit tests. I'm not even sure he published a working version. I think just the API exists. In any case, I want to try doing this with the normal task stuff. Okay, so we have a task.succeed, and then we also have task.perform somewhere down here. Yeah, which can turn our task into a command. All right. So we're going to have task.succeed, calculate next row. Then we're going to call task.perform. Oh, actually, this perform thing's a little weird because we have to handle both success and failure, but our task never fails. I'm actually just going to succeed with unit, and then have both the success and the error case always return the calculate next row. That's a little bit funky, and there's been some conversation on the mailing list about how to improve this perform function or add one that for tasks that can't fail. In any case, that's our command, and then we're going to have our message type. We only have one possible type. Then we'll have our update function, which is going to take a message and a model and return a new model. Actually, it's going to return a new model and a new command. And then we're going to have our view function, which is going to take a model and return HTML. And I'm just going to leave this as a variable because the HTML won't actually produce messages of our concrete message type. All right, so our update case message of, even though we only have one type, I'm just going to put this case statement anyway so that we'll get good compile errors in the future if we add more message types. All right, so we're going to have our model. We're going to change fractal to now equal Mandelbrot dot compute row, and the row we want to compute is the model dot next row, and the Mandelbrot model we're working with is model dot fractal. And then we're also going to change our next row to equal model dot next row plus 1. And then we're also going to do the same thing again to make a command that will immediately succeed and tell us to do the next row after that. And I guess we should probably also stop at a certain point. So let's say if model.nextRow is less than 100, and we should actually use the real height from the fractal model. Let's deal with that in a second. Okay, so if we have more rows we want to do, we'll calculate it. Otherwise, we'll do nothing. Yeah, so people in the chat are talking about using a void type for tasks that can't fail. There's actually a type in core called never, which is the same thing, but using it here doesn't actually help because you still have to define an error handling function when you call task.perform. Oh, I see. Least fixed point saying there's a function called absurd in the Elm void package that you could stick here, which is true, I think. Well, I know it's true. However, I don't really want to pull in that dependency. Let's see. So where are we at? Then we have our view, and we have our model. View model equals, and let's just call Mandelbrot.view with the model.fractal. And I think we're good to go. So finally, we want to change our main, and we're going to use now a program, html.app. And this is like a real, or like a standard program, not a beginner program, like I've often used in the past, because we have all these commands that we're producing. So specifically, we need init is going to equal incremental Mandelbrot.init. Typed this wrong here. Can't find task.succeed. Alright, I guess we need to import task. Can't find HTML. Type annotation in it doesn't match. So what did I do wrong here? Oh yeah, we never passed a size to this. So I guess let's take the size in here. And then in main, we will also take 200. Qualifier is not in scope. Yes, I typed it wrong again. And now we need subscriptions, update, and views. Subscriptions, and I'll just use an anonymous function here, since we don't need any. Our update is going to be this, and our view is going to be that view. All right, so everything appears to be frozen here. So we must have done something wrong. So let me comment this out, comment back in the old one. Oh, I can't even open the tab. Okay, import the old one. All right, now I'm going to open the Chrome inspector. Well, I can click the right thing. Inspect. Okay, we've got our console. Then put this back in, and I'm going to put debugging here in the update. Debug.log message, and let's stick a debug.log model in here too. All right, what's going on? Well, it looks like it's calculating the rows. And it also looks like it's taking slower and slower each row to calculate it. I guess that should be the case, because the center rows, any rows with black pixels are going to take a lot longer. Maybe we should put our max iterations to like 10 for the moment. So what's interesting to me is I was expecting it to render in between each update frame. But maybe that's not the case. Anyway, let's play around with this a bit. So let's make it only 100 tall. Okay, so there's our little Mandelbrot. But it's not rendering incrementally like I was expecting it to. So maybe task.succeed does things synchronously? That seems surprising to me, but we can try putting sleeps in here and see if that makes a difference. So sleep will give us a task that uses set timeout. So let's, instead of task.succeed, let's say that's process.sleep. And let's just put 1 millisecond in for the moment. And it looks like I need to import process. There we go. That's what I was expecting. So that's interesting. I was expecting that when you did task.succeed that it would actually behave in this way, but apparently the Elm runtime handles all those synchronously at the moment. So let's try doing this with a 0 millisecond delay. Okay, and then let's take all this debugging out, and it should go a lot faster. It actually doesn't. So that's interesting too, that it's taking way longer to do these rows one at a time. Okay, so I'm going to take this and extract this code to be calc next row command. That'll be private to us, so we can reuse it. This is a command of message. We will use this also here. And now we can crank this up. Let's put this back to 200 iterations. Put 400 by 400 grid. And hopefully see this render. Oh yeah, least fix point is suggesting that potentially it's slow because making so many divs in the view function. I guess that's possible. I don't know a good way to do performance on this. Yeah, that's surprisingly slow though. Are we calculating each row twice? It's only evaluating one of the calculate next rows. No, I'm pretty sure we're not doing each row twice. Yeah, this is like amazingly slow. So what's interesting is if I use the non-incremental one, set it at 400, run it. It only takes about 2 seconds to calculate the whole thing. So yeah, I would expect that. I guess the view function is fairly slow, but it's also not doing anything with the DOM. Like the virtual DOM diffing should be pretty quick because we're only changing a few of the divs at a time. But yeah, I don't know. If anyone looks into the performance of that and tries to debug it, I'd love to hear how you do it. So I'm going to go ahead and commit this and call this successful because we've successfully made it incrementally update by defining a command and on every command, calculating one of the rows, and then firing another command. So let me commit this, and then let's try to add some interactive zooming to this. All right. Let's see. I'm going to start making some notes in the README of potential future things to do. Extract a grid rendering package. Let's see. Least fixed point was just suggesting smooth coloring. So these are not things we're going to get to today, but I like to keep a note in the Git repository for future streams. Debug why incremental Mandelbrot is so slow. Cool. Oh yeah, so I wanted to show one quick thing that I learned about the other day. So there's another interesting fractal that's similar to the Mandelbrot. And basically the difference is that every time you iterate, you take the absolute value of the real and imaginary parts of Z every time you do an iteration. And it's called the burning ship fractal. So I just want to try that one out real quick. We're going to have Z. Let me call it AZ. It's going to be the complex, a new complex number where the real part is the absolute value of the original Z's real part, and the imaginary part is the absolute value of the original Z's imaginary part. Then if we just swap AZ in for Z, we should get the burning ship fractal instead of the Mandelbrot set. Yeah, there it is. And actually, like, the most interesting stuff is along in the corner and the sides. So I just wanted to show that really quick. But yeah, I'd like to go ahead and try to do zooming if we can really quick. And then leave it there at the end. So let me switch this back to the Mandelbrot. And let me also turn the iterations back down to maybe 50. I'll turn the size down to maybe 250. All right. So let's try zooming. I guess I'm hesitating again because I know we're going to have to do like bounds checking or like bounds calculations, which I'm not that excited about, but let's just jump in and do this. Okay, so I think I'm going to follow the same approach and make a new module, which will be a zoomable version. and keep our original Mandelbrot just its own independent module that only deals with straightforward calculations and display. Zooming Mandelbrot. So we're going to have a model, an init, what else? An update function. I guess that means we'll have a message and a view function. So I think the model is just going to, in fact, be our Mandelbrot model. There's nothing extra we need for this one. Then we're going to have our init. I guess this will also need to take a size. That'll take the size. Then we're going to have our message type. Zoom toward, and that'll take a complex number, I guess. How do we want to do this? We're going to click at a particular point. So I guess we're going to have the mouse location. And then we're going to have our update function. And then we're going to have our view function. And this will produce messages. So let's see. The best way to get the mouse clicks, there's kind of two ways we could do this. We could add on-click listeners to the div, and we could also try to use the mouse package and listen for the absolute mouse position. Yeah, interesting. I think I'd like to try doing it by adding on-click listeners to the div. It might make things slower, but I'd like to try doing that approach, which means we'll have to change the interface a bit in the Mandelbrot module to let us do that. Let's try it out. So we're basically going to do Mandelbrot.view, passing the model, and that's what we'll start with for now. And actually we can test it out. Let's get the update function working by adding just a cheap way that we can try this. So let's stick in a button for the moment. I'm going to import HTML exposing, and we're also going to need events. We'll have a button, we'll have an on-click, which will produce a zoom toward. Let's just say 30/30. So we'll just hard code this for now, and then we'll figure out how to make it actually interactive once we get that working. And we're going to go to our main and actually for this we're going to use a beginner program because we don't have commands. HTML app beginner program. And we'll have model equals zooming Mandelbrot dot init. We need to import. what else do we need here? Ah, I messed up in the zooming. We need to say text. And in main, we need our update and our view. All right, so what did we mess up? We need init to take a parameter. Okay. Oh yeah, and we never computed this. So let's have our zooming one always compute. All right, and we can click zoom and currently nothing happens. So let's implement this. We're going to need a function to change the viewport in our main Mandelbrot, and then we'll have to recompute. Oh, thanks, Arkham. I like doing things incrementally too. Yeah, I worked at a company called Pivotal Labs for about 4 years and really got into doing test-driven development, and which like kind of is a good practice to think of how you break things down into small steps. And yeah, also the way we would organize our product backlogs was a similar thing. So yeah, I think incremental work is a good thing. Also can help you focus as well. All right. So we're going to have a way to change the viewport. I guess that should go here before calculate. I guess we can just put the function in here. We'll zoom towards a particular pixel, and we'll take a model and we'll get a new model out. So this will be the row and the column and the model. So we're going to want the same center point, basically this. I think we can extract this as a function, which will basically take a row and column and give us the complex number that points to it. So let's take all that and we'll say C equals complex number for point, row, column. Define that. Complex number for point, row, column equals, whoops, my place, equals this. And let's see, something's wrong with my syntax here. This is going to take an int, and give back a complex. Now that is complaining. Okay. So, the focus is going to equal the complex number for point of row and column. So that's where we're going to zoom in towards. And then our new model is going to have min changed to, I guess, be halfway between the current minimum and the new focus. that gonna work? That might mess up the aspect ratio, but let's try it out, and we can do something more sophisticated later if we need to. We're gonna make a complex number where the real part is model.min.real plus focus.real, all divided by 2. And the imaginary part is the same as that. And the max is going to be the same, but using the max instead. So I don't know if that's the right algorithm to be using here, but let's try it out. Okay, so someone noted we were missing the model in complex numbers for point. Yeah, that's unfortunate. Okay. I guess I'm debating whether it would be better to pass width and height in, but let's just go for it. That means up here, also need to pass model. All right, so we click zoom. Oh yeah, the other thing we need to do here is also clear out the dictionary. And potentially we could do something sophisticated where like check if any of the pixels match up and like scale the data to be the pre-computed value, but or the previously computed value. But I'm just going to empty out the computed data for now. Means in our zooming version, we are going to take our model. We'll call Mandelbrot.zoom viewport, passing the x and the y. Then we're going to recompute. Compute all. I think we didn't expose zoom viewport. Nope. Let's go ahead and expose that. And zoom viewport, oh, my mistake, takes the row first and the column, and they're not in a tuple. All right. Hey, it worked. So we can zoom into the pixel 3030. So let's commit that. And then git commit -m and zoom pixel 3030. All right, we're down to the last step. So I'm thinking that we need a way to add the on-click listeners to each cell. So I think the simplest way to do that is Mandelbrot view. All we need to pass is the zoom toward function into the view. So this is like a configuration for the view. So I think this seems like the simplest API, and I think this will be fairly straightforward to implement. So basically the view will now take a function that can produce messages. So let's go find that view. So we're going to have a function here. This function is going to take an int coordinate and return a message. So now we're specifying what the message type must be. So this is, I'll just call it the message function, like it's a function that produces it, but we're also going to need to pass that to our row. And then we'll also have to pass this to our cell. Actually, why don't we call this, instead of message, we can call it onClick. Maybe we'll call it onClick message so that we don't conflict with the event name. And then in our cell, we're also going to take an onClick message. So then here in our div, we're going to have onClick, and we're going to call the onClick message with the X first, which is the column, and the row, which is the Y. Yeah, so actually I think that's threaded through. Does it compile? We need to import html.events. Now our view function messed up in the incremental Mandelbrot. Yes, that's true. So I guess we'll also add it here. This will be the onClick message. All right. So can we click? Tried clicking. It didn't work. So let's put debug. Whoops, wrong file. Go to our zooming one. Put a debug in the update. Debug.log message. Nope, nothing happened. All right. Let me try one thing. I'm gonna clean out stuff in the Elm stuff build artifacts cache. Make sure everything is clean. All right. So we're not getting an onClick on the divs, or we think we are. We think we should be, but we're not getting one. So let's start from the top. So in our main, we're using zooming Mandelbrot and its view. We're passing the zoom toward function. Let's see if this function ever gets called. Just put a debug.log. Cool, so it's calling all those functions, which means simply that we are actually creating the message that's put in the onClick event. So that seems to work okay. But what could be wrong here? Yeah, Arkham, I'm just Actually, I have this, the window with the HTML view is in another monitor. I'm just like switching my mouse down, clicking and hitting Command R, and letting Elm Reactor reload. Let's see, am I missing something obvious? I'm not sure why the onClick event is not apparently even getting produced, because it should be printing it out when the update function gets called, which never seems to be happening. Try making these buttons real quick. Should look kind of crazy, but there we go. Okay. So if I'm clicking right in the button, it is actually calling the function eventually. So I think something's wrong with the divs. Can you not add an onClick to a div in that way? I was expecting you could. Or it's got to be something with like the size of it. What if we put text space in here? Nope. We make all these buttons and say border none. Nope, that doesn't work either. Yeah, it seems like my onClick event not working. Let me try putting this out here. So we had a button. If we make this a div instead, click it. That works as a div out here. What if I make this a div with width and height? Import HTML attributes exposing. Oh, okay, so the text is way out here. If I click in there, that still works. Let me take the text out. I can still click in there. So that still works. So it's maybe something wrong with the containing divs are like too small. Anyway, I feel like this is an HTML problem. So let's see, if we inspect this, here's our top div. Adding. Oh, that's interesting. All of these are aligned at the wrong place. Oh, this is all shifted down. You'll notice at the top everything's shifted down by a fair amount. I wonder if that's because of the line height. Let me set the line height on all these also. So then the actual colored part we see is not inside the actual region of the div. And then we would also need to set this here on the rows. Yeah, I'm still not sure why that doesn't work. Let's see. So Nearest is asking, does every pixel need to be a button? No, it does not, in fact. And actually, the other way we could do this is using the mouse events. But the tricky part with doing that is you need to keep track of the position of basically where the fractal is appearing relative to the corner position of the screen. So it's a little bit tricky to set that up as well. You could maybe set it up to just put the on-click on the outermost div, but then we would also need to use the custom HTML event handler and use a JSON decoder to get the mouse click location within the div out of that click event. So that's also a little tricky to set up. So it's like 1:40 here. We've been going for about 2 hours. So I think I'm going to wrap this up in just a minute. Let's see. Arkham's suggesting one thing we can try for debugging. We change this to an on mouse out event he's suggesting. Or excuse me, he or she, I don't actually know. Getting events? We're not getting mouse out events for this either. But yeah, like I was saying, it seems like the color part of the div is actually below the position of the div on the screen. It's like everything's shifted down farther than it should be. So I am totally blanking on what is doing that. Like I've set up grids like this quite a bit in the past. But yeah, you can see this first div for this first row is actually too high up. So I think all the mouse and click events not actually applying properly because what we're seeing is actually outside of the bounds of each of the divs. And I'm totally blanking on what could be causing that in the CSS. So I think I'm going to leave this here for today. And if anyone debugs it, please put a pull request on the Git repo, or tweet about it, or leave a comment. So yeah, thanks for tuning in today. Like I said earlier, this was one of my favorite books growing up, and like the Mandelbrot set is just the first half of the first chapter in here. So there are a bunch of cool little programs that I want to do in the future. But I will probably just come back to this every few weeks or every so often and do more of it. And in the meantime, I do have a bunch of other projects that I want to continue and try out. I think publishing a library is one thing we haven't done yet. So maybe I'll try to make sure we have one of those to do next week. Assuming I can do it next week, I will tweet later in the week and let you know if I'll have another show next Sunday. So yeah, thanks for tuning in, and that's all for today. Let me, if anyone else is doing streaming, or if you just have your own personal projects that you want to share, feel free to let me know. And that's it for today. Have a great week. Oh yeah, and so my ending video here is another example, or I guess it's a zooming example of the burning ship fractal. So you can see some of the cool stuff in here. So thanks for tuning in. See you all later.